Okay, so recall from the last time, when you look at a geometric series, it has that R value. So the R value is that common ratio, what you're multiplying by. And if you remember from pre-cal, when your R value is less than 1, you're actually allowed to find the sum. There was that additional sum formula. So if your R is less than 1, you can say, well, the series converges, and you can actually do better than that. You can not only say that it converges, you can say it converges to, well, whatever you get when you do that formula. So when they're of this form, there's a couple other things that you can do with them. So in the first example, keep in mind that it might be written like this in sigma notation with n starting at 0. Notice when n starts at 0 that the exponent on R is just an n. But if they were to rewrite this in sigma notation where n started at 1, then the exponent would have to be n minus 1. But they're both still geometric. So it's just kind of, depending what you're starting at. So that part, just different notation. So in example 1, it says, find a power series for f of x centered at x equals 0. Give the first 4 non-zero terms and the general term. And for what value of x does it converge? So what we want to do here is if it converges, right? So it's you have to kind of work backwards. If it converges, then we know that the sum would be this thing. So in other words, what we're going to do is our goal is to set the f of x equal to this there. Well, that's a problem because then I've got a whole lot of variables, okay? So what we can do is actually eliminate a few of those variables by plugging the center in to figure out the first term, because we know that it's going to converge at least at the center. So when we plug in, so let me write it like this. I'm going to write my goal, okay? My goal is to write it in terms, right? Write as the form of that a sub 1 over 1 minus r. So if I can get it like that, then I know that it would converge in what the sum, that's the sum, so it would converge there. So first, plug in center, and that's going to help us find our a, okay? Plug in the center to get a, So in this case, we've got at x equals 0, because it told me it was centered at 0. Then, when I plug that in, I'm going to get that f of x equals 4 over 0 plus 2. So that's just 4 over 2, or 2. Okay, so this number is my a. Well, that's useful, because now I'm going to say, well, this 4 over x plus 2, that's the original f of x that they gave me. I want to write it in this form, so I'm going to set it equal to this thing. But now I know that a is 2 over 1 minus r. And obviously that is still a problem because I have an x and an r. That's okay. I want to solve this for r because my goal here is to be able to write it in this sigma notation. So for this sigma notation here, I need an a and an r. So it's okay that it's going to be in terms of x. If you think back to our previous notes, those polynomials that we had, they all had x's in them, right? So that's okay to have that as a variable. So from here, you're just going to cross multiply. Okay, so when you cross multiply, you get 4 minus 4r equals, don't forget to distribute, 2x plus 4. Very conveniently in this problem, those 4's are going to kind of cancel each other out. So you get negative 4r equals 2x. And I want to get r by itself because, again, my goal is to kind of write it in this sigma notation. So I want r by itself. So here, that means r is going to be 2x over negative 4, aka negative 1/2 x. Okay, so now I'm going to go and put it in there. All right, so what does that tell us? We say, we have the sum, and I'm going to go from 0 to infinity. That way I can write it in this form there. So my a, which I already got from over here, was 2, so it'll be 2, parentheses the r value, raised to the n. Well, my r value, I already solved for over here, so that's just negative 1/2 x, that raised to the n. So this would be the sigma notation. Did I answer the question though? Give the first 4 non-zero terms. Still need to do that, okay? So now to figure out those first 4 non-zero terms, you're literally, just extrapolating this summation out. So you start with plugging in n equals 0, then you plug in n equals 1, plug in n equals 2, and then if you plug in n equals 3, right, that'll give me 4 terms. So when I plug in n equals 0, anything to the 0 power is 1, 1 times 2 is 2, which we kind of already knew that from over here, but we get a 2, plus, now, what happens when you plug in a 1? Well, when you plug in a 1, this just becomes negative 1/2 x times 2. Well, those 2's will cancel out, so I guess I'll just get a negative x. So plus a negative x. Guess I overshot my plus sign there. Should have waited, but plus a negative is fine. Plug in n equals 2. So if you need to do a little scratch work there, so when n equals 2, be careful. It's going to be this thing squared. So that squared has to go to both pieces. So it'll be a 4th x squared. Okay, that's kind of my scratch work. Now this 2 and the 4 will cancel, so that'll be a half. So plus 1/2 x squared. And then very similarly, I'm going to do the same thing with the 3. So it would be 2 times, let's see, that cubed is going to be a negative. 2 to the 3rd, right, is going to be an 8. And then that'll be x cubed. So the 2 goes into 8 4 times, so I get negative 1/4 x cubed. So that gives me 1, 2, 3, 4 non-zero terms. I've got my general term. And for what values does it converge? That's the part I didn't answer yet. Okay, so we know that a geometric series converges when the absolute value of r is less than 1. So I'm just got to squeeze this in here. Geo converges when absolute value of r less than 1. So then this converges when I have my r value over here, right? This equals my r. So this converges when the absolute value of r, when this thing is less than 1. So now you just need to use those same rules that we did last class to break the absolute value, right? Remember, you just make this negative on the other side. So then you just have to solve the inequality negative 1 less than 1/2 x less than 1. Okay, that's how you break those absolute value bars there. And so then go ahead and, I guess, multiply everything by 2, right? So when you multiply everything by a positive 2, that doesn't mess with anything inequality-wise. So this thing converges when x is between, oops, that's a positive 2. When x is between negative 2 and 2. Okay, so this thing converges when x is between negative 2 and 2. And now I have answered the full question. Oop, missing my less than sign, so squeeze that in there. So this converges when x is between negative 2 and 2. There, now it looks good. Okay, so now it says find a power series for f of x is 1 over x, centered at x equals 1 this time. And give the first 4 non-zero. And I just use the first 4 non-zeros because that's usually what it is on the AP. Sometimes it'll only ask you for 3 if they get to be kind of nasty quickly. But a lot of times they ask you for 4. So first thing we want to do is figure out what's going on at the center. So at the center, f of x, or technically f of 1, right, is going to be 1 over 1. So I get 1. This is your a, right? So once you have a, then you say 1 over x equals, and it's a over 1 minus r, but a is 1 over 1 minus r. That's kind of my setup. You cross multiply. This one's even easier than the first one. Maybe I should have done this one first. So you get to here. And again, I want r by itself because that formula has it as the r. So to get r by itself here, you can add r to both sides and then subtract x. So you get... Either way, I think you get x minus 1 equals, negative r, or you could write it as r equals negative x plus 1. Okay, so now once I have that, I'm just going to drop it into that sigma notation. It doesn't really matter which one. I kind of like this starting at n equals 0, just because then your first term, which is a 1, right, and then the r value I just got from there, and then this is just an n. And since it says generate the first 4 non-zero terms, I'm literally plugging in n equals 0, n equals 1, n equals 2, and n equals 3. You don't have to like show this part. I was just doing that, for your notes. You would literally just write this equals, and then you could, generate the sum. So that thing equals, well, obviously when you plug in n equals 0, anything to the 0 power is 1. 1 times 1 is 1. That makes sense because that's our first term. That's why I prefer using the sigma notation starting at 0 because it makes it a little easier. When you plug in a 1, okay, so at n equals 1, I just got plus, and then you'd end up with negative x plus 1, okay, and then plus the next thing, if you plugged in x equals 2, well, there's not really much simplifying to do. It's just going to be that r value squared, right? And the last one, negative x plus 1 cubed, you know, plus dot, dot, dot. Oh, I didn't put a plus dot, dot, dot up on this top one. Plus dot, dot, dot. Okay, because that actually is going, but I was just answering the question. So make sure I answer the question. Give the first 4 non-zero terms. I gave the general term here. For what values of x does it converge? Well, again, we know that a geometric series converges when the absolute value of r is less than 1. My r value I have right here, so I just say the absolute value of this thing has to be less than 1. And again, to break that to break the absolute values, right, you set it equal to that on both sides. And now you're going to subtract 1 from each side, and then you're going to have to divide by a negative. Be careful when you divide by a negative because you are going to have to flip. Okay, so subtract 1, right, and then I'm just going to go up here so it doesn't get cut off. So I have negative 2 less than negative x less than 0. Okay, now be careful when you divide by that negative, so you're going to get 2, you have to flip the inequality sign. So this is going to be kind of weird. You have to be careful when you read this. So now x is bigger than 0, x is less than 2. So your interval there, your interval of convergence is going to be 0 to 2 this time. Okay. Okay, so Lagrange error bound, this is going to be probably on that FRQ. It'll be on the free response, and it'll be, you know, like your part D. After you generate the polynomial, it'll ask you about this. So Rn of x is the error. So read this as just error. So remember, absolute value of that's just your error, okay? Using the first n terms to sum the power series f of x. So z is going to be a number between x and c. So then basically your error is less than this expression. And you're like, yes, that looks terrible. Well,